Okay, we can start the class now. Hope I'm audible to all of you. Okay, so let's talk about some of the problems of an array. Okay, mainly one problem. Now, is there any problem with an array, or is there any disadvantage of an array? That's the first question that we are going to try and address. And related to that, we are going to look at a new concept today. Now, what is an array? Well, array is basically a homogeneous, it's a homogeneous collection of data which are stored in memory in continuous memory location. Continuous memory location means one after the other in series, right? This is continuous memory location. Now, what is the problem with an array? The problem with an array is that it stores only homogeneous data. Now, what is the meaning of homogeneous data? It means that when I enter the elements of an array, right, like I am doing right now on the board, these elements have to be of the same data type. They have to be of the same data type. What does it mean? It means that when I declare an array, the array should be of one data type. It could be an integer, it could be a float, it could be a char, anything, right? However, if we declare it as an integer array, this array has got a constraint, right? That all the elements which we enter into an array must be an integer. Now, this is one issue that we have in an array. Now, we should have more flexibility with this structure. We should be able to, kind of add elements into an array which are not of the same data type. If we can do that, we achieve a greater flexibility in our structure. What do I mean by that? What I mean is, rather than having an array which can store only integer values or only floating point numbers, if I can have an array which can store mixed data type, okay, if I can have something like an array which can store mixed data type, that means I can store an integer, right? I can store a floating point number too, 6.5, and I can store a character also, right? Or for that matter, I can store a string, right? So if I can have an array which can store data or which can have elements of different data types, it gives me a huge, great flexibility. Okay, so in today's class, we are going to see how we can resolve or how we can overcome this issue or a disadvantage of an array and have something by which I can store different data types in a structure similar to an array. Now, one of the properties of an array is that these values that you have here, these items or these elements that you have here, they are stored in continuous memory location. So if this is your memory, the elements are stored one after the other next to each other. And that is the reason pointers come into the picture here, because using a pointer variable, you can directly access the elements of an array by using pointer arithmetic. So if you do ptr plus 1, it goes to the next memory location where the second element of an array is present. If you do ptr plus 2, then you go to the next memory location where the third element of an array is present. So today we're going to introduce a concept which is called as a structure. Okay, so which is called as a structure. What is a structure? What is a structure? Well, a structure is similar to an array. It's similar to an array. However, structure can store homogeneous data. Okay, now array does not allow us to store homogeneous data. Array allows us to store only homogeneous data, but a structure allows you to store heterogeneous data. What I said was wrong. Structure allows you to store heterogeneous data. Now, structure is another user-defined data type. Array is also a user-defined data type. That means I can define this data type, right? It's user-defined. Why it's called as user-defined? Because I have a control over the size of an array, right? I can define array. I can, specify, okay, what will be the name of an array and what will be the size of an array. So the memory I can control the memory allocation of an array. So that's why it's user defined. Similarly, structure is also a user defined data type. So it is a user defined data type which is available in C. It's also available in C++, but we are not going to consider this right now. It's available in C, and this allows data types of different kinds to be stored in continuous memory location. So structures are very useful when we have to represent a record. What's a record? Like if I ask you a student record, right, or an employee record. Now, if you look at a student record or an employee record, or for example, books in the library, right? So each of these record, they have multiple data items. For example, let's look at a student record. If you have a student record, what are the different attributes or the different data which is associated with the student? Definitely the first thing is going to be the roll number, right? So roll number is going to be one element of one record, one value that a student will have. He will also have an age. He will also have a name, right? He will also have his marks, the total marks, let's say grades. So I can say CGPA. So CGPA is basically the cumulative grade per, average, right? Now all this 4 data types here, or he can also have a gender, right? He can also have a gender, male or female. So let's put it here, like male or female. So these data types together can be called as a record. Okay, so this is one record. So for one student, I can store his roll number, let's say 3, his age 22, his name MANAS, say my name, CGPA 6.5, and gender can be male. Similarly, I can have the record number. This is record 1. This is record number 2. I can have another roll number 4, having age 21. Name can be something something. CGPA can be 7.5, and can be a female, right? So if you notice, this is how lot of real life application data is represented as a form of a record. Okay, so if we have to handle these data type, so it will be a wonderful thing if I can store these data type into a structure similar to an array. But array will not allow it, because a roll number can be an integer, age can be an integer, name will be a character array, CGPA will be a floating point number, and you have gender, which will be a character. So you see that there is a mix of different data types. So arrays will not allow me to store these values, right, together, because these values represent one person's record, one student's record. So they need to be stored together. That's where the structure comes into the picture. So structure is a user-defined data type in C, which will allow us to overcome this problem of an array, and it will allow us to store homogeneous data items in the memory, just like an array in continuous memory location. So structures are used to represent a record. If you want to keep track of books in the library, if you want to store the address of someone, address is also made up of different data types, right? You have your house number, you have your street name, you have your lane number, you have your state, and your what you call the district, and you have your pin code. So you have a mix of different data types, right? So a structure is very useful. So before I move ahead and show you exactly how we can create a structure and how we can write it in a program, I just want a small confirmation if you all understood what I have told you till now. Have you all understood?
Yes, sir.
Okay, fine. So let's move on then. Okay, so how do you define a structure? So how do you define an array? So when we define an array, we normally write something like this, right? So you define the array, the name of the array is going to be, suppose, age, right? So here is the array which you define. That's it. This is how you define the array. Now this means, what it means is an array, suppose I have 5 elements here. So an array of 5 memory locations are created, right? This is named as age, and I can enter the 5 data here, right? How do I access these elements? How do I access these elements? I can access it by age 0, right? I can access it by age 1. So these are the indexes. So this index is 0, this index is 1, and so on, and this index will be 4. So I can access these values by writing age 0, age 1, age 2, so on, right? So this is how we declare an array. Now, how do we declare a structure? So the first thing, the structure has to be declared by using a keyword. Now, this is something important. struct. This is a keyword. Now, this is a word. Why it's called as a keyword? Because you cannot use it as a variable name or a function name. It cannot be used by the user, the programmer. This is a reserved word in C. So we must declare this structure data type with this struct keyword. Okay, so that's very important. Second, I need to define, just like age, right? Just like I write age, I need to, for example, in place of integer, I put structure. That means this is a new data type which I'm trying to define. Is it an integer? No, it's not an integer. What is it? It's a structure. Okay, so the structure has to be written with the keyword struct. Now, just like I write age, I have to write basically the name of the variable. So what is going to be my data structure name? What is going to be the name of my data structure? In this case, I'm using the data structure to store the age of 5 people, but in the structure data type, I'm going to store the information of books in a library, say, right? So how do I store, so let's say I write the name of this structure as books, okay? And now, if I do this, basically this represents an array, right? So I can't do this. So for a structure, now I have to define all the different types of data which is going to go inside this, okay, which is going to go inside this. So I can have an integer, right, which will be the book ID. So this is the first, data type which is being, defined in a structure. So here is my structure going to be something like this in the memory. It has got only one data type. So right now only one allocation will be done. Let's say another thing called, let's have an array called title, right? So I define an array of size, say 50. So a second allocation is going to be done. Now let's say this book has got a price. So let's declare something as float, right? And there will be a price for the book. So now there is another memory allocation done for the price. So this is how a structure is defined. So this is my structure. Okay, so my structure is ready. So this is how, just like how you define your array, I have defined a structure. Now what this is going to do is, this is just a declaration of an array, of a structure. That means I am telling the compiler that if anybody creates a variable for this data type, this is a data type which I have created. What kind of data type is this? This is a user defined data type. Now, using this data type, I can declare variables. Like for example, when I have integer, I can declare A, B, C, right? So for A, a memory allocation is done. For B, a memory allocation is done. For C, a memory allocation is done. Similarly, for this, I have to write books, right? This is the data type name, right? Because this is the data type name for me. Like integers, I have created a data type called as books. So I have to write B1, books, B2. Similar to A and B, I have declared B1 and B2 as two different variables of what kind of data type? Books. What is this books? This is a user-defined structure data type. Okay, so as soon as I write books B1, a memory allocation is done by, by looking at the definition which is provided. What is the definition which is provided? The definition of the structure says that I need 3 memory locations. So 3 memory locations will be allocated in the memory. The first memory location is an integer. So what is going to be the size of an integer? So if my size of an integer, say, is 4 bytes, right? So let's say this is the one. If my 4 bytes, so the first memory allocation will be of 4 bytes. If my second is character, it's an array of 50. So here is my 50 bytes of memory location for this. And the third one is price. If that is 8 bytes, so 8 bytes of memory location will be done for this. Okay. So as soon as I write books B1, a memory allocation is done. If I write B2, another memory allocation of the same dimensions are done here as well. Okay. So now after this is done, I can start using these memory. I can initialize the values into this and do some operations or store those values and kind of display it when the user wants, and all the other operations can be done. So can you just quickly tell me if you've understood this entire structure definition right now? Then I can go ahead and show you in the
Yes, sir.
program how to do it. Yes, right?
Yes, sir.
Yes, sir.
Okay, great. So let's write a simple program and see exactly how this entire structure works. I'm going to write a very simple program. Okay, so we're not going to take too many attributes. We're just going to take a very simple 2 attributes, and we will see exactly how it works. Now, before we go ahead, okay, let's try to do that. So let me write my hash include. Okay, so that's something that we all know of. Just give me 1 minute. Okay, yeah. So that's my hash include stdio.h. Now what I'm going to do is I'm going to define my structure. So let's say I put my struct keyword. That's how we define a structure. And I'm writing a structure called as test. Okay, this is just a test that we're going to do. And in this, I have one variable that's all integer a, right? And let's add another character, or we can add another float to make it simpler. We can add characters later. So float f. Okay, so there are only these 2 variables. So let's close my structure. So I close my structure. So my structure is already defined. So this is my data type. Okay, what is the name of my data type? It's a test. What is a kind of data type? It's a structure data type. Okay, now let me start my main method. So here is my main method. Okay, now in the main method, now I can create variables for this data type. Okay, so normally how do I create variables? I write int a. So in this case also int is a data type and a is the variable. So here my data type is test. So I should be writing something similar to that. So I write test t1. Okay, but just remember one thing, that in C, when you're declaring a structure, right, you have to also write the keyword struct here. This is an additional thing that you have to write here. Okay, so when you are declaring a structure variable, you have to just declare it like a normal variable. This is the data type, but you have to write this keyword struct. Okay, just keep a note of it. Other than that, everything is same. But when you come to C++, I'm just giving you a small information. In C++, there is no need for you to write this struct. That has been removed. Anyway, we will not talk about it. We are talking about C, so we will look at the structures in C. Okay, now the important thing is, as soon as you write this line of code here, what's going to happen? A memory is going to be allocated for you. There you go. And this memory is allocated. So how many blocks will be there? 2 blocks. How will the compiler decide that there's going to be 2 blocks? Because it is going to check this particular definition of the structure. And in the definition, we have said that there's going to be 1 integer and 1 float. So if integer is 4 bytes, so this 4 bytes will be allocated, and the value of this will be garbage value here, because nothing is going to be put into that, because we have not yet initialized any value. But just a memory location of 4 bytes is going to be allocated, and another memory location. If float is 8 bytes, then this will be 8 bytes. And this is what happens when I write this line of code. And this has the name test. Test is a variable, which is, sorry, test is not the variable, T1 is a variable. So T1 is a variable which is pointing to this particular memory location. Important thing to note, this and this will be continuous. That means the memory locations for these 2 blocks will be adjacent to each other. They are going to be in continuous memory location. Now, this is similar to an array, but the only difference is I can store an integer value here and I can store a floating point value here. Now, in an array, normally how we used to access this? We used to access by writing T0, and here we used to access by writing T1. Okay, then we used to access by writing T2. Now this was possible because each of those blocks were of the same size. In an array, the size of these blocks are the same, right? So T0, T1, T2 will move, the pointer or move the index, to similar block size. But in a structure, this is not how we access the elements of this particular structure. So how do we access? Now we have to access by using T1, right? And we don't write 0 or 1 here, but what we do is we have to access it by using the variable name that we have defined above in the structure. So T1.a, you can access this memory location. T1.f, you access this memory location. Are you able to understand this much?
Yes, sir.
Yeah. So remember that
Yes,
when you're
sir.
accessing the elements in a structure, you use an operator. This operator is called as a dot operator. So if I create another structure, say I'm creating another structure test T2. Now what's going to happen? Another memory location is going to be created with 4 bytes and 8 bytes, and this is going to be pointed by T2, right? Now if I need to access this memory location here, how will I access? Can anyone tell me?
T2.a.
Absolutely. So T2.a, this
T2.a,
memory,
T2.f.
and T2.f. There you go. Perfect. Okay. So that's how we access memory locations of a structure. Now, very simple. So now, since we can access this, we can always initialize values into it, isn't it? You can always initialize a value there. So how do we initialize a value there? Very simple. You can straight away write T1.a is equal to 10. So 10 goes here, and T1.f is equal to 5.5. So here we go, 5.5, which is a floating point number. So I write f here. So 5.5 goes here, right? Now I have initialized the values of my structure, right? Similarly, I can do for T2 also. Now, once these values have been initialized, I can use these to do any operations. I can display it. So if I write printf and if I do T1.a, right, this T1.a will access this 10. If I do, printf T1.b, T1.b will access this one, T2.a will access this one, and T2.f will access this one. Okay, so this is a simple program of how structures can be defined. Now what's important in this program is this one. This is how we can define a structure. This is how we can create structure variables. Right here we are creating a structure variable. So this line we are creating a structure variable, this line we are creating a structure variable, and here we are initializing the values of a structure, and you can access it by using the dot operator. So this is important. So from the context of a structure, this is important. This is how you declare a structure, define the elements of a structure. This is where you initialize a structure variable. Sorry, this is where you declare a structure variable, and this is where how you access the memory of the structure data. So far so good.
So
Yes, sir.
just a question.
Yeah.
Sorry for the
Okay.
interruption.
So
Sir, if you want to store a data in T1.a during runtime, so you have to write like %d and address of T1.a.
anything, if you want to initialize in runtime, then you can create this test dynamically. You can create T1 dynamically. Okay, so you have to use malloc, and using malloc you have to create this structure dynamically, and you have to take the pointer which the malloc returns, and you have to put it into a structure array. So your pointer variable will be something like this: struct test star ptr. This is going to be the pointer variable, and this ptr is equal to malloc, and you will be doing the memory allocation here.
Okay, sir.
Understood?
Okay, sir. Thank you.
Okay.
Yes, sir.
Actually, I'll write it in a little clearer way so that others can also read it. So this is how you do dynamic memory allocation of a structure. So you have to define a structure variable, right? So my structure name is test. So I will give ptr here, right? And this ptr will be used in malloc. Okay, I will be specifying the size here. So I can do size of test, This will calculate the size of the structure. What is the size of the structure? And then I can typecast this to test, because that's my data type. Like how I used to do it for integer, I can do it for test. And this will store the address dynamically now. PTR is the handle for this dynamically allocated structure. Okay?
Yes, sir.
Yes, sir.
Okay, fine. Now the first point is, what is going to be the size of the structure? That's important. What is the size of an array, and how is the size of an array going to be different from the size of a structure? So size of an array is very simple. So if you have an array of 3 elements, and if it is an integer array, right, and if the integer is 4 bytes, then what is going to be the size? Size is going to be 3 into 4, which is equal to 12 bytes. Right, integer 4 bytes, 4 bytes, 4 bytes into 3 is equal to 12. But what is going to be the size of a structure? The size of a structure is a little bit more complicated. If you have an integer, you have 4 bytes. Say if you have a float, you have 8 bytes. Suppose you have a double or a character, let's say 1 byte. So this is a char, this is a float, and this is an int. So what is going to be the size of what you call the structure? It is going to be 4 plus 8 plus 1, which is equal to 13 bytes. Now, when you write a program and find the size of the structure, you will find that it doesn't match to 13. It's more than 13. Always you'll find that there'll be some value which will come more than 13, and you'll get confused. Like sir told us that it's going to be the sum of all the sizes of all the data types which are being declared in a structure. But here it's not coming that way. I'm getting more than 13. So what happens is the compiler uses some extra bytes to do some padding and all that. Okay, in order to separate the 3 data types, compiler uses some padding. You know what's padding, right? Padding is basically keeping some gap between the 2 different memory locations. All right, so suppose you have a cupboard. If this is your cupboard, okay, and if your cupboard size is say 6 feet by 4 feet, or whatever it is, like it's a closet or anything, it's a sideboard or whatever, and if your size is 6 feet by 4 feet, now if suppose you're going to create partitions in this, so when you make a partition, right, this is the partition, this is how you create a partition. So now when you create a partition like this, sorry, it's gone. So when you create a partition like this, and if you calculate the size of these areas now that you have, don't you think this will be less than the total 6 4 the 24 square feet? If you combine the size of all these areas, it will be less than the total size of this. Why it will be less? Because some amount of space is going in these partitions. This is also taking some small, for example, 1 inch, 1 inch, 1 inch to 1 inch, that much of wood you're using. So that wood is taking up the space which is there in this. So if you want a exact 6 by if you want an exact 24 square feet of size, then you have to increase this a little bit more, so that when you put in the wood, so if you have say 26 square feet, and then if you put these partitions suppose are taking 2 square feet, so now your area is 24 square feet. So actually you will think that it is 24 square feet, but the you have to increase the size of the cupboard a little bit more by 2 square feet. So similarly, in order to accommodate this 13 square feet, in order to do these partitions and keep the values from mixing, the compiler uses some padding and all, and it allots some little bit of bytes and bits to it to separate these values in the continuous memory location. So that's why you'll find that this size does not come out exactly. It may come out exactly, it may not come out exactly. So don't get worried if you run a program and you find that the size is different. And that size again differs from compiler to compiler. Some compilers will allot different size of bits. Some compiler will allot more bits to separate. So depending on the compiler, you will get different values. But effectively, the size of your the structure will be the sum of the 3 different data types which you have defined in a structure. Okay, is that fine?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, great. Now you know how to access a structure. Now I'm going to give you a small example, and I'll show you that if I take the structure and kind of represent it with an array. So let's go back to a previous program. Where is a program? Okay, here. Okay, let's write a fresh one so that it doesn't get confusing. So I'm writing the same program again. Okay, so I'm declaring the structure, and this time I'll try and use some space here. So it was int a, and we had float f, right? So here's my structure. That's it. Structure is defined. Let me write my main. So I have my int main. Okay. Now I'm creating a structure variable. So struct struct. So I write test t1. So everybody is fine till now, right? Now, just like how I use a normal data type and put it inside a pointer variable, I can do all the same operations here also. So let me create another pointer variable. So I will write test star, say ptr. This is my pointer variable, right? Now, before I actually do anything here, let me initialize the values of t1. That means a and f values, right? So t1 basically has two values, a and f values, and I need to initialize them. So let's initialize them. How do I initialize them? Let's access this. So t1.a, let's say it's 10, all right? And the floating point number, let's initialize that also. So t1.f is equal to, say, 5.5f. I hope you know why we're writing f. In order to represent floating point numbers, we need to write f at the end of it. If you don't write f, by default, it is converted into a double. Okay, so here are my two values. So a is initialized with 10 and f is initialized with 5.5. Okay, now what we'll do is, let's use this pointer variable and store the address of t1 into it. So we know how to do it, right? So you can take ptr. Now ptr is a pointer variable which can store the address of what? It can store the address of a memory location which is pointed, which is memory location which is storing a structure, because I have declared that pointer as test. So it is storing a structure. What type of structure? What is the name of the structure? The test. Okay, so I can do ptr and t1. All of you okay with this step? I think you should be okay because we've done lots of these programs, right?
Yes, sir.
Okay, now if I want to print the values of a and f, now I have got the address. So basically here is my, t1. This value t1 was pointing to this. This had 10 and this had 5.5. Now what I did was I took the pointer variable ptr. Now ptr is pointing to the memory location here. Okay, ptr is basically storing the address of t1. So now if I want to access these values using ptr, I cannot do ptr dot a. I cannot do ptr dot a. Okay, I cannot do ptr, sorry. I cannot do ptr dot a, or neither can I do ptr dot f. I can't do this. So how can I access this? So I can access the variables here, the values of these variables, not by using a dot operator, but in this case, I will be using an operator which is called as arrow operator. So if I need to print the value a, right? So sorry, making mistakes. So I need to write a is equal to %d, right? So what I need to do here is I need to write ptr arrow a. Okay. Similarly, print f. I want to enter the value f here. So this is the floating point access, format specifier. This is the decimal format specifier. So here I need to write ptr arrow and f. Okay, and return 0, whatever it is. So just remember one thing: if you are accessing a point, if you're accessing the elements of a structure, if you're accessing the values of the data types inside a structure, without using a pointer variable, by using a structure variable like T1, I use a dot operator. Okay, I use a dot operator. But if I use a pointer variable which is pointing to this memory location, which holds a structure, and if I want to access the elements of those, then I need to use a arrow. Okay, is that clear?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So these are two important things in a structure. Now you can use a structure just like how you use array. You can pass a structure into a function, right? You can pass a structure into a function. You can pass the pointer to a structure into a function. So there are a lot of things that you can do. You can do everything with a structure just like what you do with an array. So in today's class, I have just given you the introduction of a structure, right? Now, structures are very useful because it's important to understand this concept of structure, because later on when you're going to study a high-level programming languages like Java, if you're going to study C++, and when you come across the concept of object-oriented programming, you know, we will be taking this structure to another level. Okay, so the same concept that you're learning right now, this same concept is, you know, used in object-oriented programming, but with lots of additional features. So if you understand structure properly, it will be useful for you. Okay, so structure, again, I'm just doing a summary of what I taught you today. Structure is again a user-defined data type, right? It's a user-defined data type which can store different values. Now it is different from an array. It is different from an array because in an array only homogeneous data types are allowed. That means you can store the data types of the same, you know, type, integer or float. But in a structure, you can mix the different kinds of data types, and structure allows you to store that. Important thing is that in a structure as well as in an array, all the elements are stored in continuous memory location, and that's the most important thing. Okay, and I also told you how to use a structure, how to declare a structure, how to initialize the variables of a structure, how to access the structure elements. So if you're accessing the structure elements by using the structure name, you use a dot operator just like here. But if you are accessing the structure elements by using a pointer variable, then you need to use this arrow. Okay, so that's, I think, good enough for today's class. So if you have any queries, please ask me.
So just a question.